Alrighty then, we're going to be talking about graphs of functions here in section 1.3. More domain. I know that we talked about domain in section 1.2 and 1.3. We'll be talking more about domain, find the domain, and also introducing the range as well. Alrighty, so let's get cracking here. All right, so the graphs of a function, and this right here is a function, right? And we know that because it passes the vertical line test, and not just that though, but every x value, okay, like only has one y value here, okay? So every graph is a collection of like ordered pairs. So we have an x number, and then we have our y number, okay? And there are like infinite number of these points right here, right? There's not just a point here at 2, -2, but there's also a point here, and there's a point there, and this thing just keeps going on forever, right? I mean, there are infinite points here on a graph, infinite points on this quadratic right here. So, and you know, the way that you find points, right, is that like you plug in 2, right? Like you plug in 2, and then like output your -2, so that's a coordinate point. All right. So when we start talking about domain, okay, domain of a function is the set of all the values, the set of all of them, all the values of x for which a corresponding value of y exists. Meaning, if I have a point right here, there's going to be some x and then some y. And then if I have a point here, there's some x and some y. Okay, so the domain is referring to all of the x values, all of the x values that are used to graph our function. Okay, that's a way that you can think about what is domain. Domain are all the x values that are used to graph our functions, and so that's why our domain is going vertical or is going horizontally right here, because it has to do with the x-axis. And then the range are all of the y values that correspond to the x values in the domain. So it's all the y values that were used to graph this. And as you can see here, say this range would stop right here at that value, and then it's just going to go up, because as the graph keeps increasing, well, so then will the range. So what we want to do right now is let's do a number of examples of finding the domain and the range. Okay. All right, so we want to find the domain and range of our function f of x. All right, so it's a radical expression, and it's radical x plus 3. So let's check this out here. Here's the graph. It's already graphed for us. So all we want to do is write down what is the domain. Okay. Okay, so if you think about this, look at what is the smallest x value that this graph has? Right here, right? -3, 0. It doesn't go any smaller because -4, -5, -6 is not part of the graph right here. It starts at -3, 0, and it goes to the right. So the way that we can say what is the domain can be the set of all x values such that now it starts at -3. It starts at -3. Oops, I wanted to. X starts at -3, and then it just goes, it gets bigger. So it's when x is greater than or equal to -3. This would be our domain. Okay, just so that this makes sense here, listen. What x values were used? Well, -3 was used, and then -1 was used, or -2, -3, and then we used the x coordinate 0, we used 1, we used 2, we used 3. So see how all these x values were used? I mean, and it keeps going, right? It's going to keep going further to the right. So what this notation means is it's all the x values such that only when x is greater than or equal to -3. Only when x is greater than or equal to -3, because it starts at -3. It starts at -3, and then it goes to the right. Okay. Another way that you could have represented this is that it starts at -3. We put a bracket, and then it goes on forever to the right, which means it goes infinity, which means that we're going to do the infinite symbol, which is the laying down infinite sign, and then they're going to use parenthesis. Okay, you always use a parenthesis when you are doing your notation for domain, because you can never reach and never obtain infinity. So you're going to have to use a parenthesis to do infinity there, okay? Now what about the range? Okay, the range now are all the y values. What y values were used to graph this? Well, look, if you look at the y value, see how if you correlate this all the way to right here, it starts at 0 and it goes up, 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 and it's going to keep going up and up and up. So if you look at just the y-axis, that's it. The range means the y-axis. If you look at just the y-axis, it starts at 0, and this graph is going to go up and up and up and up and up and up, and as it keeps going up, the range keeps going up. So it's going to pretty much almost be the same thing here. So it's the set of all y values such that y is greater than or equal to 0. Or you could have represented it as it starts at 0 with a bracket, and then it will go on for infinity, and I'm going to use parentheses right there. Let's do example B here. All right, so we want to use this graph to find the domain, and then after we find the domain, we want to go ahead and find the range and then do this evaluation. So let's do part A. Let's find the domain. Okay, so remember the domain means what x values were used to graph this. So let's just look at the x-axis. Okay, if you look at the x-axis, the furthest that this goes is -1, and the furthest to the right it goes is 4. Does that make sense there? See how the furthest to the left is -1, and it goes all the way to 4. So the way that we can represent our domain is we can say it starts at -1, and notice that because it's a closed circle, it's going to be a bracket, and then it goes all the way to 4, but since it's an open circle, it's not included, so I'm going to use a parenthesis. Another way that you can represent this, or you can represent it as x right here, right? So x is bigger than or equal to -1, but it's smaller than, but it's not going to have equal to 4. Okay, if it has an open circle, then you are not going to put the equals symbol right there in the inequality. If it does have a closed circle, then you are going to put the equal then symbol. So I say or because it's the same answer, but it's just two ways of representing the same thing. Okay. Now let's do part B. Part B says find the values of these two things here, f of -1. Again, what this means is if I plug in -1, what's the y value? So watch this. Go to -1. If I plug this value in -1, the y value is bing right here, you see? If I plug in -1, go to the graph. If I plug in -1, see what the y value is? It's -5. 1, 2, 3, 4, 5. So f of -1 is -5. See how this is the coordinate point? This is the coordinate point -1, -5. This is the x value. This is the y value. And let's also plug in 2. What happens if I plug in 2? Well, go to 2 right here. If I plug in 2, what is the y value? If I plug in 2, the y value is 4. So f of 2 equals 4. Last but not least, let's find the range. If I want to find the range, we want to find what's the lowest value on the y-axis that this goes to. All right, so let's do that here. So the lowest y value down here is -5, and the highest y value is 4. See right there? The lowest value is -5, and it goes all the way up to 4. So the way that we can represent this is we can say that y, okay, check this out here, is in between -5 and it goes up to 4. Closed dot means we have the equal symbol. Closed dot means that I could use the line right here, okay? So this means y is in between -5 and 4. Or of course, you could do the brackets in parentheses. So you could go, it starts at -5 and it goes up to 4. Bam. So both of those are the same. Either one would give you the correct answer.